This is part 2 of the complete one-way ANOVA, looking at the relationship between time of day and attention. In the last video, we ended with our basic ratios, which are summarized here below. So the next step in this process is to calculate our sums of squares. And in the one-way ANOVA, there are 3 sums of squares. The first sum of squares is the sum of squares A. And the formula for this is really simple. It's simply the basic ratio for A minus the basic ratio for T. So we have 2380 minus 2366, which is 14. And again, I always encourage you to pause this video as you're moving through this and do the calculations on your own rather than just writing down the answers that I put on the screen. Our second sum of squares is our sum of squares S over A. And the formula for this is the basic ratio for Y minus the basic ratio for A. So we have 30, I don't know what's going on here. We have 30, hang on. We have 3130 minus 2380, which equals 750. And then our last sum of squares, I don't know what is going on with my brushes here. Our last sum of squares is our sum of squares T, and the formula for that is Y, the basic ratio for Y, minus the basic ratio for T. So we have 3130 minus 2366, which equals 764. And remember, before you move on from this step, you want to check your work. Your sum of squares A plus your sum of squares S over A should equal your sum of squares T. And we can do this one in our head. 14 plus 750 does, in fact, equal 764. So that checks out. All right, next we are going, I don't know why it keeps doing this, next we are going to calculate our degrees of freedom. And for each one of these sums of squares, we are going to calculate a corresponding degree of freedom. So we're going to have a degree of freedom A, S over A, and T. This is probably the easiest step of the problem. The formula for degrees of freedom A is simply little a minus 1. And remember, little a is the number of groups or the number of levels. So in this problem, we have 2 minus 1, which equals 1. Our degrees of freedom S over A is little a times the quantity n minus 1. So our little a, again, that's the number of groups, and our little n is the number of subjects per group. So this is 2 times the quantity, 7 minus 1, which is 2 times 6, or 12. And finally, our degrees of freedom T is A times N, no parentheses, minus 1. So we have 2 times 7 minus 1, which is 13. Oops. Which is 13. And before we move on, we want to check our work. So just like the sums of squares, our degrees of freedom A plus our degrees of freedom S over A should equal our degrees of freedom T. So 1 plus 12 does in fact equal 13, so that checks out. There is, as I've mentioned before, a second way of checking your degrees of freedom T. So your degrees of freedom T, sorry, hang on a second. Your degrees of freedom T should be 1 fewer than your total number of observations or your total number of observations is the best way of thinking about it. So going back to your data, you can see we have 14 data points. So your degrees of freedom T should in fact be 1 less than that. So 14 minus 1 is 13. So that's another good thing to check out. All right, so once we have our sums of squares and our degrees of freedom, we are ready to calculate variance. And in the ANOVA, the term for variance is the mean squares. All right, so remember, the overall formula for variance is always sum of squares divided by degrees of freedom. That's kind of the universal formula for variance. Sum of squares divided by degrees of freedom. So you can see in this problem we have 3 different sums of squares. We have 3 different degrees of freedom. So technically we could calculate 3 different variances or 3 different mean squares. Now customarily we only calculate 2 because we don't really need the mean square T for anything. So we're going to start with our mean square A, and all we're going to do here is match up our sums of squares with their corresponding degrees of freedom. So our mean square A is going to be our sum of squares A divided by our degrees of freedom A. So we've got 14 divided by 1, which is 14. Our mean square S over A is our sum of squares S over A divided by our degrees of freedom S over A. So our sum of squares is 750 and our degrees of freedom is 12. And when we do the math on that, that equals 62.5. And I've mentioned this before, there's really nothing that we can do to check our work at this point. Our mean squares should be positive, as should our sums of squares. We shouldn't have any negative numbers in here. If you have a negative number, you have certainly done something wrong. So these should be positive numbers, but beyond that, there's really nothing else we can do to check. Sometimes mean square A is bigger, sometimes it's smaller, they don't add up to anything, and adding in the mean square T doesn't really help us with a check, so we usually don't calculate the mean square T because we don't need it. This brings us to our final step, our final mathematical step, which is calculating the F ratio. And F in the one-way ANOVA is equal to the mean square A divided by the mean square S over A. And remember, the mean square A is our between subjects variance, and the mean square S over A is our within subjects variance. So we're just going to take these numbers from up here. Our mean square A is 14. Our mean square S over A is 62.5. And when we do all the math on that, we get 0.22. So in the next video, I'm going to put all these numbers together in the ANOVA summary table, and then we are going to evaluate our F ratio.